Hi, and welcome to 2.4 for college algebra of our trig component, application solving real world problems. We're just going to use some trigonometry today. So a couple things we need to understand. First, angle of elevation and angle of depression. So when I talk about angle of elevation, whenever we have a little guy, we can build a horizontal that is parallel with the ground. From that horizontal, whenever you're going up, this is the angle of elevation. Okay. Whenever you are parallel with the ground and you are going down, actually, let's do this. Whenever you are going down, this is the angle of depression. Now, if this is also parallel with the ground, we find that these two things are parallel. And this is actually a geometry concept where this angle and this angle are alternate interior angles. All that means is conceptually they are congruent. So, as long as you draw it correctly, an angle of depression and an angle of elevation in the context of this would be equal angles. Now, let's get into something you probably haven't seen before. Uh, well, I can always do a y-axis and an x-axis together, and I'm going to label them all four cardinal directions. So north, east, south, and west. So the way this works for directionality, whatever is listed first is the axis you start on, and whatever angles are over here are the direction you go. So for example, north 45 degrees east, I would go north and I'm going to go 45 degrees towards the east. Now if we were to try it again, over here, it says south 30 degrees of west. So it starts south and I'm going to go 30 degrees towards the west. So that's how those angles are determined. Okay, let's try one. A 75-foot pole casts a shadow 43 feet long. What's the angle of elevation of the sun? Angle of elevation would be right here. So from the perspective of that theta in my right triangle, the 43 is my adjacent and the 75 is my opposite. So we get tangent of theta equals opposite over adjacent. Therefore, theta equals tan to the -1 of 75 over 43, which we can type right into our calculator. So we get about 60.2 degrees. A boat travels on a course bearing north 52 degrees east. I'm sorry, 52 degrees 40 minutes east for 238 miles. How many miles north and east is the boat from the starting point? So, north is my starting axis. So, when I draw it from there and I go that way, that's where the 52 degrees 40 minutes goes. The problem is when I construct my triangle, that angle isn't within my triangle. So I have to remember that that is technically 90 degrees. So the first thing I would do if I'm trying to find my theta is theta right there would equal 90 degrees minus 52 degrees and 40 minutes. Remember now I need minutes so I can take out a degree. And there are 60 minutes in a degree, so this is an equivalent expression. So we would get 37 degrees and 20 minutes, which is why inside my triangle we get 37 degrees, 20 minutes right there. Now, from the perspective there, we also got to remember that 238 is along my hypotenuse, and my x, that's my hypotenuse. My x is my adjacent, my y is my opposite. So if I'm trying to find my x, what uses adjacent and hypotenuse? Well, that would be cosine. And if I'm trying to find my y, what uses opposite and hypotenuse? That would be sine. So we get cosine of that equals x over 238, because again, that is adjacent over hypotenuse. And here we get opposite over hypotenuse. So we get x equals 238 cosine of 37 degrees, 20 minutes, which we can type right into our calculator. Where the degrees and minutes are in second apps for the angle. So we get x is 189.2. And you can even go second enter to just turn this into a sign instead of retyping that whole thing. And that'd be 144.3. So these will both be miles. And y is miles north. And x is miles east, because that's the direction we are going, in the horizontal direction to the east and in the vertical direction. Okay. Thank you for listening, and I hope you have a great day.